anything over itself is 1. 3 over 3 is 1. Negative 4 over negative 4 is 1. This also means anything over its opposite is negative 1. Negative 3 over 3 is negative 1. 3 over negative 3 is negative 1. Why? Well, because anything over itself is still 1, but when we have two different signs, that makes it negative. If we expand this to rational expressions, anything over itself is 1. So x plus 2 over x plus 2 is 1. And because we can add in any order, x plus 2 over 2 plus x would also be 1. Because x plus 2 is the exact same thing as 2 plus x. Now, that doesn't hold up with subtraction. Now, anything over itself is still 1. X minus 2 over x minus 2 would be 1. But it's a completely different story if we have x minus 2 over 2 minus x. What happens when we subtract two numbers in a different order? Well, again, adding 2 plus 3 is 5, 3 plus 2 is 5. Adding it doesn't make a difference. Subtracting 3 minus 2 is 1. 2 minus 3 is negative 1. 6 minus 4 is 2. 4 minus 6 is negative 2. So if we switch the order of subtraction, we get opposites. A number divided by its opposite, well, we just talked about how that's negative 1. So when we have the same order but flipped, so I guess when we have the other order, when we have the same numbers but flipped order, with subtraction, that equals negative 1 overall. What's another way of writing a number and its opposite? Well, if x is a number, then the opposite of x would be written negative x, which is a little confusing because sometimes negative x is not a negative number. If x was already negative, this would actually be positive. So I try to remember to say x and the opposite of x, but I'm going to say minus x. I'm going to say negative x. These are how we talk about these things. If the number is x plus 2, then the opposite of x plus 2 could also be written as negative x minus 2. I'm distributing that negative sign. So x plus 2 over negative x minus 2, that's a number over its opposite. X plus 2 over negative x minus 2 would be negative 1. Why am I pointing this out? Well, here's our next example. X minus 5 over 25 minus x squared. Let's simplify this rational expression. Well, that's x minus 5 on the top, and the bottom is going to factor, since it's a difference of squares, to 5 plus x times 5 minus x. We can't actually cancel x minus 5 and 5 minus x unless we cancel them and leave over a negative 1. Then this would become negative 1 over 5 plus x. From that canceled factor of 5 minus x, there was some information there. 5 minus x can't be 0. So negative x can't be negative 5, and x can't be positive 5. Positive 5 being plugged in for x is the thing that makes that factor 0. We don't have that information at the end. X can't be positive 5. X also can't be negative 5, but we still see that at the end. Don't worry too much about, do I put it, do I not put it? I'm writing it to be complete. Unless the problem is specifically asking you for a restricted value, don't worry. The important thing is that you can reduce it to here, which could also be negative 1 over x plus 5, because we can add in either order. 5 plus x is the same as x plus 5. So again, we need to be able to recognize that x minus 5 over 5 minus x is negative 1, that it's something over its opposite, because then we can cancel them away and leave a negative 1 behind. I want to show another way to think about this. It still requires you to recognize, and you better recognize, so let's bring it all the way back to, hey, we factored the bottom, we got 5 plus x times 5 minus x. We can't cancel these, but I can multiply by anything over itself. I can multiply by 1. 1 is anything over itself. I can multiply both the top and bottom by negative 1. But I'm only going to multiply it through down here, because I want to flip one of them. So on top, I have negative 1 times x minus 5 still. I'm just switching the order. On the bottom, I have 5 plus x times, well, what happens if I multiply this by negative 1? That's negative 5 plus x, or x minus 5. X plus negative 5 is x minus 5. Multiplying a -1 through one of them is going to switch it around. And then we can just cancel normally, and we can see we're left with -1 over 5 plus x, or -1 over x plus 5. Let's do another like that, just to get a little more practice in. Let's take a look at 20 minus 5x over x squared minus x minus 12. The bottom factors, we need numbers, x and x, numbers that multiply to -12, add to -1. Those numbers are going to be +3 and -4. Multiply to -12, add to -1, +3, -4. On the top, 20 minus 5x, we can factor out a 5, and that leaves us with 4 minus x. If I multiplied top and bottom by -1, but only actually multiplied one of them out, that leaves me with the 5 and a 4 minus x and a -1 on top. On the bottom, it'll be an x plus 3 times a x plus 3 times a 4 minus x. Multiplying a factor by -1 ends up switching the numbers around the subtraction sign. From here, I'm going to lose some information that x can't be 4. So I'll make a note of that. Or not, I'm not being explicitly asked. Don't make a big deal about having to have that part. The important part is the simplified answer. The simplified answer, 5 times -1 is -5. And on the bottom, we just have an x plus 3. -5 over x plus 3. If you wanted to write x can't be negative, or x can't be +4, feel free. It's actually more correct if it's there. Quick note about something like -5 over x plus 3. There are 3 different ways to write this. This negative on top can also be written on the outside. This would be the same as negative on the outside. Or the negative on the outside can also come to the bottom, but if you do that, it can't just be -x plus 3. It has to be in parentheses, -x plus 3. 5 over -x minus 3. So these are all the same thing. And you can write it in any of those ways. But 5 over -x plus 3 written like that, that's not correct. If you move the minus from the top to the bottom, it has to be multiplied by the entire bottom, or multiplied through. So it wouldn't be minus x plus 3, it would be minus x minus 3. If we had PQ, R, and S as numbers, then P over Q times R over S would be P times R over Q times S. When we multiply fractions, we multiply across the top, we multiply across the bottom. For instance, if we had 2/3 times 5/7, this would be 2 times 5 over 3 times 7, which would be 10 over 21. That's multiplying without needing to reduce at all. Similarly, if P, Q, R, and S were polynomials instead of just numbers, we do the same thing. So if we had 2x over 3y times 5z over 7, we would multiply across the top, 2x times 5z. We would multiply across the bottom, 3y times 7. Two times 5 is 10. X times z is xz. All over 3 times 7 is 21. And we have the y. Now what about reducing? Let's go back to just numbers. Let's say we had 7/10 times 15 21sts. Well, we are allowed to do the same thing. It's the base rule, so it will work. We would have 7 times 15 on the top. We would have 10 times 21 on the bottom. And remember, multiplying across the top, multiplying across the bottom, that might naturally be what you want to do when you look at this, but it only works for multiplication. If we were adding these two fractions, we wouldn't add across the top and add across the bottom. If we were subtracting, we wouldn't subtract the tops and bottoms. If we were dividing, we wouldn't divide the tops and the bottoms. So this straight across on top and bottom, numerator and denominator, that is only for multiplication. And what do we get here? Well, since this is times 10, the 210 on the bottom is the easier of the two, for me at least. Got to do 15 times 7, 5, carry the 3, 105. So we get 105 over 210. This is a fraction that would need reduced. So we could look for common factors. If that ends in a 5, that ends in a 0. If I divide the top by 5 and I divide the bottom by 5, that should give me an equivalent fraction. So 105 divided by 5 is 21. 210 divided by 5 is 42. And you know what? Now I can see it. But just in case you can't, that's fine. Let's say maybe divide top and bottom by 3. There are other numbers that'll work, that'll get us farther along. 21 divided by 3 is 7. 42 divided by 3 is 14. And here I can divide top and bottom by 7. I end up with 1/2. Took me a while, but I did end up there. Another way we have to reduce, maybe you notice that's exactly half. You divide them both by 105. You get 1/2 right away. But when we do math, we like to use methods that'll work every time, no matter what, that are especially useful with big numbers. And most often it is factor trees that are our path when it comes to reducing. Factor trees to get prime factorizations. So 105, I know we just did this, but it was 5 times what? 5 times 21. 5 is a prime factor. 21 is 3 times 7. Those are both prime factors. So 105 is 3 times 5 times 7. 210 one way to break that up quickly is 21 times 10. 21 is 7 times 3. 10 is 5 times 2. These are our prime factors. 2 times 3 times 5 times 7. The 7s cancel, the 5s cancel, the 3s cancel. Leaves us with just a 2 on the bottom. And would it be a 0 on top because it's all gone? No, because that's like having 1 times all that. That leaves a 1 up top. So prime factorizations and then canceling gets us to the answer of 1/2. So all these different ways we have to reduce when we get 105 over 210, multiplying across the top and multiplying across the bottom. Okay, so this is still a review of very old material. This is before this course, well before this course. To avoid having to reduce at the end, we're able to cancel. We're able to look at our original multiplication problem, and this is something we can only do with multiplication, and reduce anything on the top with anything on the bottom. So for instance, 7 over 21 is 1/3. Or you can think 7 and 21 can both be divided by 7. 7 divided by 7 is 1. 21 divided by 7 is 3. 15 over 10, both of these can be divided by 5. 15 divided by 5 is 3. 10 divided by 5 is 2. Three and 3 can both be divided by 3. 3 divided by 3 is 1. 3 divided by 3 is 1. We've canceled everything we can, and that leaves us with 1 times 1 over 2 times 1, which is 1/2. Look at that. We never had to deal with 105. We never had to deal with 210. This way is nicer when we're able to do it with just numbers. And this is how we multiply polynomials as well. Let me show you what I mean. Actually, I do want to show one more thing about that 7/10 times 15 over 21. You know how we did prime factorizations of the big numbers? Watch what happens when we do prime factorizations of each of these. 7, that's 1 times 7. 10 is 2 times 5. 15 is 3 times 5. 21 is 3 times 7. Multiply across the top. Multiply across the bottom. Cancel common factors. We're left with 1/2. Let's do this with this problem. 5a minus 5b over 10 times 2 over a squared minus b squared. You might look at this and go, wow, that was an escalation. We're going to do the exact same thing. We're going to factor all 4 parts of this. So factoring that, we can take out a common factor. Always do that first or our methods do not work. Always factor out a common factor if we have it. We can factor out a 5 and we're left with a minus b. We can factor this. A squared minus b squared, that is a difference of 2 squares. A squared minus b squared is a plus b times a minus b. We're doing prime factorizations if we just have numbers. 2, well, 2's already prime. 10 is 2 times 5. I've factored everything. Let's cancel what we can. 2's cancel. A minus b's cancel. 5's cancel. Nothing else cancels. If we go across the top now, there's nothing left. But remember, any of these could be times 1, so really we have a 1 left. On the bottom, all we have left is a factor of a plus b. So 1 over a plus b is our answer. Now, remember I said before that once we got past our initial work with finding restricted values, we wouldn't mention the restricted values unless we're specifically asked going forward. So we wouldn't have to find any restricted values, not for just multiplying. However, if we go back through our work, variables in play at the bottom would be A and B. A plus B can't be 0. That means A can't be the opposite of B. And A minus B can't be 0. That means A can't be B. So the numbers can't be the same, and the numbers can't be opposites. Plugging in two numbers that were the same for A and B, or plugging in two opposites for A and B, would cause this fraction to be undefined, which would cause the whole thing to be undefined. But we're not asked anything about that here. We just want to multiply and simplify. So let's do more multiply and simplify. And before I erase that, why was I able to cancel this A minus B over here with this A minus B on the bottom of the second fraction? They're not in the same fraction. Well, once everything's factored, multiplying these together has the same effect as jamming it together, multiplying the top and multiplying the bottom. So even though we didn't see it as as one whole fraction, even though we saw it as multiplying two separate fractions, in effect, once everything's factored, anything on the top on either of them is the top of the same fraction. Same with the bottom. So anything from the top can cancel with anything on the bottom, just like when we cancel here. Let's do more. These are going to get gradually more and more difficult, not in what we're actually doing, because what we're doing every time doesn't change. Factor every piece of every fraction. Cancel common factors. Multiply what's left. Next, let's look at 3y minus 6 over 6y times y squared plus 3y plus 2 over y squared minus 4. So what we're doing every time doesn't change, but what will change every time is the level of factoring that'll be required of us. Here, in the top left, we can factor out a 3, and that's all we can do. We're left with 3 times y minus 2. Three is already a prime number, so we don't have to break that up any further. If you want to show less steps than I do, I don't recommend it. That is your prerogative. But if you're missing problems because you're not showing as many steps as I do, that's going to be That's going to be on you. The more steps you show, the less you have to do in your head. Get it down on the paper. Just like saving work back in the old days. Down here, bottom right, there's no particular order. I'm just doing what I see. I like to do what I think might be easiest. Y squared minus 4, that's a difference of squares. It factors as y plus 2 times y minus 2. Now the 6y, there's nothing we can factor out, but 6 can be broken down to its prime factorization of 2 times 3. So just for ease of things canceling. There we go. Sorry about that. So like I was saying, the 6y, I'll just rewrite this. Some technical difficulties. The 6y, we can't really factor, but this 6 can be broken down into its prime factorization, 2 times 3. And here, the y squared plus 3y plus 2. We need numbers that multiply to positive 2, add to positive 3. Those numbers are plus 2 plus 1. So this factors as y plus 2 times y plus 1. Let's cancel what we can. This 3 with that 3. This y minus 2 with that. Y minus 2, y plus 2, and y plus 2. Which leaves us with just the factor of y plus 1 on the top and just a 2y on the bottom. Y plus 1 over 2y. Let's do another. 4w minus 20p over 2w squared minus 50p squared times a numerator of 2w squared plus 7wp minus 15p squared. Wow. All over 3w plus 9p. Since it's going to take up the most room, I want to factor this one first just because of the space that I have. As we begin putting answers in, I'm going to lose my space. So let's factor this. Recall that if we have two variables and they're spread out with like a w squared here, a p squared there, both w and p in the middle, we want to think about two w squared plus 7w minus 15. I'm taking the p out of it completely. I'm going to do the airplane method, which is going to require a corrective step because we're going to start with 2w and 2w because we have that 2w squared. It's going to need a corrective step because, of course, 2w times 2w is not 2w squared. It's actually 4. So at least one of these will divide at the end. We need numbers that multiply to a times c. We need numbers then that multiply to negative 30 and add to positive 7. This is plus 10 and minus 3. 10 times negative 3 is negative 30. 10 plus negative 3, 10 minus 3 is positive 7. We put in our plus 10, our minus 3. The 2 and the 3 don't divide by anything, but the 2 and the 10 both divide by 2. And that leaves us with w plus 5 times 2w minus 3. But wait, that's not right. Why isn't that right? Let's write that down here. W plus 5 times 2w minus 3, because that's this one without the p's. So we're just going to put a p after the 5 and a p after the 3. W plus 5p times 2w minus 3p. If you don't believe me, you can check that out. If you FOIL that, you're going to end up with 2w squared plus 7wp minus 15p squared. Okay, after that one, the rest of these are going to be easier to factor. This one we can factor out a 3. We're left with w plus 3p. Here, we can factor out a 4. We're left with w minus 5p. This one, let's factor Let's factor 2w squared minus 50p squared. Greatest common factor first, we take out a 2. We're left with w squared minus 25p squared. And that's a difference of squares. W plus 5p, w minus 5p. Don't forget that 2 we factored out in front. 2 times w plus 5p times w minus 5p. Okay, factor everything. Here, that 4, I'm going to go ahead and rewrite that as 2 times 2 because I'm going to cancel one of those 2's. W plus 5p with w plus 5p, w minus 5p with w minus 5p. We're left with on the top is one of the 2's times 2w minus 3p. On the bottom, 3 times w plus 3p. And we wouldn't multiply this back through. We're going to keep this in factored form because that shows that we did reduce this as much as possible. Our answer is 2 times 2w minus 3p over 3 times w plus 3p. Let's do another one. All that changes is the stuff that we're factoring. And considering that coming into today, we did know how to multiply regular fractions, the new stuff isn't really new either. So we're just doing different things. P squared plus 8p plus 16 over 10p plus 10 times 2p plus 6 over p squared plus 7p plus 12. I'm not going to bother color coding this time. I think we're getting the hang of what we're doing. We're just going to factor everything we can. Top left is going to factor to p plus 4 squared, or p plus 4 times p plus 4. Here, we can factor out a 10. We're left with p plus 1. Over here, we can factor out a 2, and we're left with p plus 3. Down here, bottom right, we need two numbers that multiply to give positive 12, that add to give positive 7. This is plus 4 and plus 3. P plus 4 times p plus 3. What can we cancel? Well, I'm going to go ahead and rewrite the 10 as a 2 times 5, because I'm going to cancel that 2. P plus 3 with p plus 3. And one of the factors of p plus 4. So instead of p plus 4 squared, p plus 4 times p plus 4, we're just left with the single p plus 4. What does that leave us with? On the top, just p plus 4. On the bottom, 5 times p plus 1. That's it. And again, we won't need to mention that p can't be negative 3, that p can't be negative 4. But we do want to show the work so that when we look back, we can see, hey, we did factor, cancel a factor of p plus 4 in the bottom. Why would we keep these things in mind? Well, let's say this was part of an equation. Later on in a future lecture, we might have this equals something. And after simplifying, we go on to solve for p. Well, we would need to check our answer against the restricted values. Without all this work here to look back on, we wouldn't be able to see that negative 4 is a restricted value, that negative 3 is a restricted value. And don't worry, once it's important again, I will start hitting you over the head with, hey, is it a restricted value? That'll be once we get to equations. We did our practice with restricted values in the last lesson. We're focused on being able to actually multiply and simplify right now. What comes after multiplication? Well, division. So let's very quickly look at how we would divide. If we had fractions, let's go straight to the numbers. If we had 8/9 divided by 4/3, the kernel can help us out. We have a finger-licking good method of dividing fractions. Keep, flip, change. Keep, flip, change. What? Keep the first fraction, flip the second fraction, change division to multiplication. I put it in that order because KFC, nice and easy to remember. But keep, change, flip if you want to go left to right. And once we keep, change, flip, or keep, flip, change, we have a multiplication problem. And we know what to do with a multiplication problem. Next up, let's take a look at this. We're just going to jump right into the deep end. 8t cubed plus 27 over 9 minus 4t squared divided by 4t squared minus 6t plus 9 over 2t squared minus t minus 3. Now I'm going to start you out with a warning. This top right one, if you start there, try to factor this, you're not going to be able to. This one does not factor. You won't be able to actually find the numbers in this case that would multiply to positive 36 and add to negative 6. They don't exist. We can't factor that. Not to worry though, we can factor these other three. And as soon as we factor the top left, you're going to feel more comfortable about not factoring this one. Now, some people might see the division problem and want to change it to a multiplication by flipping the second fraction right away. Don't do that. I'm going to explain why. Hopefully you heed my warning. But the first step is going to be to factor everything, just like it was in the multiplication problem. Factor everything first before we do anything else. So, top left, this is a sum of cubes. This is 2t cubed plus 3 cubed. Remember, we have our SOAP formula. It's a sum, same, opposite, always plus. 2t and 3. The 2t squared gives us 4t squared. Multiplying them together gives us 6t. Squaring the 3 gives us 9. See that? That leftover piece of the sum or difference of cubes that never factors. It's the exact same as what we have here. Hopefully that makes you feel better about leaving it like this. Maybe by the end it'll cancel away and we won't have to worry about it at all. Down here, the 9 minus 4t squared, that's a difference of squares. So we're going to have 3 plus 2t and 3 minus 2t, because that's 3 squared minus 2t squared. This is still a division problem. I already warned you that one's not going to factor. But bottom right, here we want numbers that multiply to a times c, multiply to negative 6, add to negative 1. We'll put those numbers in a 2t times 2t. We use the airplane method, do our corrective step. These numbers that multiply to -6 and add to -1 are going to be +2 and -3. We put those in, +2 -3. Our corrective step will go here, dividing both by 2. And we get t plus 1 times 2t minus 3. T plus 1 times 2t minus 3. Okay, why was it so important that we factor before changing to multiplication? Well, changing to multiplication flips the second fraction. Here we see a t plus 1 and a 2t minus 3 on the bottom. That means in this step, what do we get in terms of restricted value information? We get that t can't be -1, or this fraction is undefined. Once we flip it, these go to the top. They're not on the bottom anymore. If we never see it written on the bottom, we don't know that t equals -1 will be a restricted value. So we have to see it completely factored in division form first, because there will be things on the bottom there that won't be there once we flip it. And once we flip it to get a multiplication problem, we'll have, keep the first one, 2t plus 3 times 4t squared minus 6t plus 9 over 3 plus 2t times 3 minus 2t times, changing division to multiplication, flipping the second fraction. So the t plus 1 times 2t minus 3 is on top. And the 4t squared minus 6t plus 9 is on the bottom. Now I erased my work. You'll still have yours up there. You'll see that division problem. I just need more room, as always. And looky here, 4t squared minus 6t plus 9 cancels, top and bottom. Nothing else on the top and on the bottom looks exactly the same, but let's recall our previous conversation. In the last lecture, about forms of 1. 2t plus 3 and 3 plus 2t, those are exactly the same thing, because we can add in any order. We saw last time that this equals 1, therefore it cancels away. We can add in any order. Subtracting is what throws us off. And before we worry about that, let's write what we have. We have t plus 1 times 2t minus 3 on top. We have 3 minus 2t on the bottom. We can't just cancel these because they're not the same thing. What does 2t minus 3 over 3 minus 2t give us from our conversation in the last lecture? Gives us -1. So if we cancel these, we have to be left with a factor of -1. So -1 times t plus 1. And we wouldn't write -1 times, we would just write negative times the quantity t plus 1. Or if you want to negative t minus 1, write it without the parentheses, you can do that too. That's all we have here. Let's do another division problem. X squared plus x over 5x cubed minus x squared divided by 10x squared plus 12x plus 2 over 25x squared minus 1. Let's factor everything first. Keep it division. Top left, factor out an x. We're left with x plus 1. Bottom left, factor out an x squared. We're left with 5x minus 1. Bottom right, this is a difference of two squares, 5x and 1. So 5x plus 1 times 5x minus 1. Here, let's factor 10x squared plus 12x plus 2. Step 1, factor out a greatest common factor. We have to do it. If it exists, we have to do it first. Airplane method, if you don't bring that 2 out, it's going to give you the wrong answer. So our methods overall will only work every time if we take out the common factor first. We're left with 5x squared plus 6x plus 1. We would need numbers that multiply to 5 times 1, multiply to positive 5, and add to positive 6. When we find those numbers, we'll put it in a 5x times 5x because of our 5x squared. Then we'll have a corrective step because we don't need 25x squared. We need it to be 5x squared. The numbers that multiply to positive 5 and add to positive 6 are plus 5 and plus 1. Put in a plus 5, put in a plus 1. This one divides by 5 for our corrective step, and we're left with 2 times x plus 1 times 5x plus 1. If you're struggling with these and it's because of the factoring, all I can say is you have to review factoring more. You have to practice factoring more. Okay, we have our division problem. We have everything factored as much as we can. I'm going to write it as a multiplication problem now. For you, that'll be the next step on the page. For me, I have to erase because I need room. Room. Keep the first one. Change division to multiplication. Flip the second one. So the 2 times the x plus 1 times the 5x plus 1 is on the bottom. The 5x plus 1 times 5x minus 1 is on the top. What cancels? 5x minus 1, 5x plus 1. X plus 1, and one of the factors of x. How many more where? One of them on the bottom. So what's canceled? Everything from the top. And what does that mean? 0 because everything's gone? No. Since 1 times whatever is whatever, we're still left with a 1 on top. On the bottom, We have x times 2, 2x. 1 over 2x is our final answer.